since we don't have any missing values, we will go into inferential statistics, hypothesis testing. Next session, we will talk about data preprocessing, which is a very large subject. We will use a new data that has a lot of issues in the data. We will go and clean up the data and all. We will understand various steps of the data preprocessing using the data. Okay. So today we will discuss inferential statistics or hypothesis testing. Okay. So inferential statistics, in which hypothesis testing is one of the most critical tasks. Hypothesis testing is comparison of means or averages of two groups or classes or levels or more than two groups or levels or classes. Hypothesis testing is comparison of means. Comparison of means. Not median, not standard deviation. It is comparison of mean or average. In hypothesis testing, we compare the mean or average. Typically, in hypothesis testing, we have hypothesis testing. We can see we have situation like one variable numerical and other variable categorical, or both variables categorical or non-numerical. So in hypothesis testing, we will have one variable numerical and other variable categorical, or we will have both variables as categorical or non-numerical. The fundamental assumption in case of numeric variable is that it must be continuous, closer to normal distribution, with minimum outliers and no missing values. This is the assumption for the numeric variable that we are going to have. So typically, the hypothesis test will have either one numeric variable and one categorical variable, or both variables as categorical variables. Basically, hypothesis testing will tell you whether there is a relationship between two variables or not. In terms of effect. In terms of the effect, statistical effect of one variable on the other. That is what the hypothesis test will tell us. In layman terms, you can say it will tell us the relationship between two variables, one numeric variable and one categorical variable, or both numeric or both categorical variables. You have a test for both numeric variables also. We call them as bivariate statistics. That also we will discuss. Now, the process of hypothesis testing is, first you need to do the group by. You need to do group by. I forgot another fundamental assumption. One more fundamental assumption of hypothesis testing is the means or averages of the groups or levels or classes must be different. This is another assumption. The means or the averages of the different groups or levels in the categorical variable must be different. If the means are equal, you should not conduct hypothesis testing. You will conduct hypothesis testing only when the means or averages of the groups or levels or classes is different. Now, the group by function, which we were using in the last session, will confirm the mean difference. Will confirm the mean difference and also highlights how many levels or classes or groups in categorical variable. So the group by function will tell us two things: whether the means are different. Second, how many levels or categories are there. If I scroll up and show you the group by function of one example, here we see the season. How many levels are there? 4 levels are there. 4 levels or groups or classes. Different textbooks use different words. In the season categorical variable, there are 4 levels, 4 categories or 4 groups or 4 classes. And are the means different? The means are different. So the group by function will tell us whether the means are different or not. Second, it will tell us how many levels, groups or classes are there, because that will affect the test which we are going to do. The test which we need to implement is based on the number of levels or groups in the categorical variable. So the group by function will tell both those things. Second, you will frame the null and alternate hypothesis. You will frame the null and alternate hypothesis. 3, you will split data into as many levels or classes or groups. You will split the data into as many levels or groups or classes. Then you identify and conduct the relevant hypothesis test. You will conduct the relevant hypothesis test. And the 5th step is the interpretation of the test is based on p-value, also called as probability value. So the interpretation of the test is based on simple p-value. You will get a p-value. Based on that p-value, you will interpret the test. Now, what is this interpretation I'm talking about? Interpretation based on p-value. P-value less than 0.05, we will reject the null hypothesis. If you are rejecting the null hypothesis, what we will do? You will accept the alternate hypothesis. So if you are rejecting the null hypothesis, you will accept the alternate hypothesis. But we only talk in terms of null hypothesis. The interpretation is simply based on null hypothesis. P-value greater than 0.05, we fail to reject null, which is nothing but accept, but we can't use the word accept in statistics or machine learning. We will say fail to reject null. Fail to reject null means we are accepting the null hypothesis and we are rejecting the alternate hypothesis. Now you might get, what is the 0.05? 0.05 means 5% alpha or probable error rate and 95% confidence level. 0.05 means 5% alpha or probable error rate and 95% confidence level. So let me repeat. Hypothesis testing is comparison of mean or average of two groups or more than two groups. Only mean comparison, not median, not standard deviation. There will be in some tests one numeric and one categorical variable. In some tests, both will be categorical variables. The fundamental assumption in case of a numeric variable in the test is the numerical variable must be continuous, closer to normal distribution with minimum outliers and no missing values. The other assumption is the means of the groups must be different. You will conduct hypothesis test only when the means are different. If the means are equal, you should not conduct hypothesis test. Mean difference is a fundamental assumption. And what will help us to find out the group by function? The group by function will help us to find out the mean difference and also help us to find out how many levels are there in our categorical variable. Because the number of levels in the categorical variable will decide the type of hypothesis test that we are going to choose. The type of hypothesis test depends on number of levels or groups or classes in the categorical variable. Okay. Then the process is, first you need to do group by. Second, you will frame the null and alternate hypothesis. I will tell you the format, how the statement has to be framed. Third, you have to split the data. Manually, we have to split the data into that many levels. In case of season, we have 4 levels. Season 1, 2, 3, 4. So we have to split our data frame into 4 levels. Season is equal to 1 data frame. Season is equal to 2, 1 data frame. Season is equal to 3, 1 data frame. 4, 1 data. That splitting we have to do. Then we will identify the relevant test based on the levels and we will conduct the test. Once the test is conducted, as part of the output, you will get the p-value. As part of the output, you will get the p-value. We will go with the p-value based interpretation. P-value less than 0.05, reject null hypothesis. P-value greater than 0.05, fail to reject null hypothesis. Fail to reject null means accept null hypothesis, but we can't use the word accept. It is either reject or fail to reject null. 0.05 means 5% error rate, also called as alpha, and 95% confidence levels. Across machine learning and statistics, whenever you see p-value, it must be less than 0.05. In algorithms also, we will see p-values, but not in Python. When we go to R being a statistical software, there you will see a lot of p-values. In Python, we don't get these p-values because Python is modified to work as a machine learning language, not as a statistical language. Whenever you come across p-value, that means it must be less than 0.05. Less than or equal to. Less than or equal to. See, in real-time statistics, we will go up to 0.06 also. Some journals accept p-value 0.06 also as reject null hypothesis. So that's a very marginal difference. So less than equal to or slightly 0.58, 0.058. That also considered as less than 0.05. So that we can take a liberty and we can choose our own decision. Less than equal to or slightly higher than 0.05, marginally higher, we will take it as reject null. That is accepted. Okay. There will be two statements in hypothesis, null and alternate. I'll tell you what it means. We have to frame them. They are the statements which are framed based on the business problem we are doing. The null and alternate hypothesis depends on the business problem or the variables you are dealing with. It is different from situation to situation. I can say equality is assumed as null, non-equality is assumed as alternate, but you will get confused. So let us frame it. Once I frame the statements, then you will understand. Then you will be able to relate to the equality and non-equality of the terms. Okay. So null and alternate hypothesis depends upon the variables you are dealing with. But there is a certain standard format, certain keywords have to be there in the statement. What are those keywords? I will explain to you once I frame the statements. Those keywords must be there when you are framing the null and alternate statement hypothesis. Okay. Any doubts till now? Can we move forward? Yeah. We'll do. We will do all the tests. Now, let us say I have to conduct a test. Test null, the average CNT on holiday 0 or 1 equal. So typically a statement will be given like this: test null, the average CNT on holiday 0, 1 is equal. So what are the variables here? CNT and holiday. CNT is numerical, holiday is categorical. So here CNT is the numeric variable and holiday is categorical variable with how many levels? With exactly 2 levels or groups or classes. What are the 2 levels? Yes or no? No being 0, yes being 1. So when you have this situation, one variable numeric and other variable categorical with exactly 2 levels or groups or classes, the hypothesis test we will do is 2 sample independent t-test. If one variable is numeric, the other variable is categorical with exactly 2 levels, not less, not more. exactly 2 levels. The hypothesis to be conducted is 2 sample independent t-test. 2 sample independent t-test is the test we need to conduct if the categorical variable has exactly 2 levels. Now, how will I know there are exactly 2 levels? Bicycle data dot CNT dot group by bicycle data dot holiday dot mean. So we have exactly 2 levels and the means are also different. Exactly 2 levels or classes or groups. And then the mean or average are different. The mean and average are different. Wait, don't jump. Let us understand the first test. This test itself is a very complicated test. We have to understand this, then only we will go to the next one. Yeah.
What is that one variable numeric and one other variable in that holiday?
What is CNT? What type of variable is this?
Numeric.
What is holiday?
Holiday is
So what is the doubt?
but in
Does this standard is meant to conduct a 2 sample independent t-test? There must be one numeric variable and one must be categorical variable. Is that condition is met or not? Then when will you do 2 sample independent t-test? When the condition of one variable numeric, the other variable categorical with exactly 2 levels is met.
So we have to check by that group by.
Yes, group by has to be used to check. That's what I clearly written here. The test depends on how many levels are there in the categorical variable. So here we have exactly 2 levels. So with the test which we have to use is 2 sample independent t-test. Clear? 2 sample independent t-test is used when there is one numeric variable. The other is categorical variable with exactly 2 levels. Then only you can use 2 sample independent t-test. The null hypothesis for this test is there is no significant difference in average CNT of holiday 0 or 1. No significant difference in average CNT. No significant difference means what? It means you can treat both the means as equal. In layman terms, we can say both means or averages can be treated as equal in statistical terms. Numerically, they are not equal. Numerically, they are not equal. See, we all have this assumption, right? A person who scores 86 and a person who scores 88, we treat them equally, right? Even though the numbers are different. Anything between 85 to 90, we treat them as equal, even though numerically they are different. Statistical equality, not the numerical equality. Now, what is alternate hypothesis? Alternate hypothesis is the exactly same statement. Alternate hypothesis exactly same statement, but you will remove the word no before significant. In alternate hypothesis, you remove the word no before significant. There is significant difference. That means we cannot treat both the means as equal. no significant difference means we can treat the means equal. Significant difference means we cannot treat the means equal. The difference between null and alternate hypothesis is the word no before the word significant. That is the only difference between two statements. The word no before significant. No significant difference is null hypothesis. Significant difference is alternate hypothesis. If you are looking at equation terms, the null will be H0 mean 1 is equal to mean 2. Alternate hypothesis HA would be mean 1 not equal to mean 2. Exclamation is equal to is not equal to. Exclamation equal to is not equal to. Equation wise. Or you can also write like this. Some people write like this. H0 is equal to mean 1 minus mean 2 is equal to 0. Or you can also write like this. Alternate hypothesis is mean 1 minus mean 2 not equal to 0. Equation wise, you can write like this. So, equation wise, you can write the null and alternate hypothesis like this. Now, visualization would be like this. So, two-tailed test. Generally, we use two-tailed test, rejection on both the ends of the bell curve. Rejection on both the ends of the bell curve. That is what equality suggests. We always use two-tailed test in business, which is null hypothesis is equal to, alternate hypothesis is not equal. In basic statistics, we have one-tailed test. Right-tailed is greater than, left-tailed test is less than, greater than. But in business, we only go with two-tailed test, rejection on both the ends. Rejection on both the ends of the bell curve. Just remember that it's a two-tailed test we generally do. The null hypothesis is equal to, both means that can be treated equally. Alternate hypothesis is both means cannot be treated as equal. Okay, so this is the standard format. Always what you do is you will change the variable names. That's all. The statement is till here similar. Only thing is you have to change the variable names. There is no significant difference in average. There is no significant difference in average. There is significant difference in average. And then you change the variable names. Okay. So this is the hypothesis testing of a two-tailed, two-sample independent t-test, which is conducted when you have one numeric variable, the other categorical variable with exactly two levels. With exactly two levels. Okay. Any doubt till now? Now, for t-test, for two sample independent t-test, variance difference is also checked. For two sample independent t-test, variance difference is also checked. Check using group by variance difference, whether the variance is different or not. We have checked the mean difference. Now check the variance difference. The function for variance is dot var. Using the group by function, find out if the variance is different or not.
What's the function, sir?
Where? Here. Is the variance different? CNT dot group by bicycle data dot holiday dot var. Okay, so we are getting this. So NP dot round. If you want the actual values, round it. NP dot round, comma 2. 2 decimal. Round is for rounding off. NumPy. NumPy has the function called round. We are rounding off to 2 decimal. NP dot round, open bracket, bicycle data dot CNT dot group by, open bracket, bicycle data dot holiday, close bracket, dot var, null brackets, comma 2, close bracket. Now the variance is also different. The variance is also different. Variance is also different. All right. So for two sample t-test, you have to check the mean difference. You also have to check the variance difference. I'll explain you why. Now, split data. You have to split the data. Holiday 0 is equal to bicycle data, name of the data frame, square bracket, we are subsetting based on condition. Bicycle data dot holiday double equals to, when you are using is equal to as logical operator, you have to give it 2 times. Double equals to 0. Holiday 1 is equal to bicycle data, square bracket, bicycle data dot holiday double equals to 1. Now we are creating 2 subsets of the data frame. One holiday 0, one holiday 1. One data frame, all the values holiday 0. One data frame, all values holiday 1. You can check. Print holiday 0 dot shape. Print holiday 1 dot shape. We have 21 rows where holiday 1 is there. We have 710 rows where holiday is 0. Total size of the data is 713. When you are splitting the data, be careful. This is the common where most people may make a mistake. All of you go to Google and type scipy.stats, SCIPY.stats. Go to Google and type scipy.stats, SCIPY.stats. Here, scipy, SCIPY.stats. Scipy.stats is a library within the NumPy that has the statistical functions. Scipy.stats, SCIPY.stats. All right, scipy.stats. This is a library, sub-library of NumPy, which is having the statistical function. Control F, type t-test. Control F. Control F will open a box and then type in the box t-test. Control F and t-test. Now I have gone to the t-test, right? Statistical test, t-test you can see here, highlighted in yellow color. Now what we want to calculate the t-test for means of two independent samples of scores. Calculate the t-test for the means of two independent samples of scores. So this is the function, t-test underscore ind. The function is t-test underscore ind. Click on it. Once you click on it, you will go to the function code, t-test underscore ind. Now there is an argument called equal underscore var is equal to true. By default, it will assume equal of variance is equal to true. But is it true in our case? Is the variance equal? No, we have to change this argument. Equal underscore var is equal to false. Because by default, it assumes equal underscore var is equal to true. That is why we have to check variance and we have to give this argument equal underscore var is equal to false. And look at it. It is a two-sided test. We are looking at equality, right? Two-sided test. Default is two-sided test. Now, what is the output of this test? The output of this test is, if you come down, see here, it returns t statistic. I'll tell you what is the formula for t statistic, and it gives you the p-value. It gives you the p-value. T statistic and p-value. T statistic is the formula for t-test. I'll give you the formula. Now, you might say, what is the null and alternate? So, the null and alternate hypothesis is given here. The null hypothesis that two independent samples have identical averages. No significant difference means what? Identical averages. So you don't need to remember that text in the documentation only, you will see the null hypothesis. Null hypothesis is two independent samples have identical average. Alternate would be the two independent samples have non-identical average. And the population have identical variances, but we don't want to go with it. We have to make sure the variances are different. Right? All of you got the understanding of the documentation. Scipy.stats, Control F, give the test function, name of the function. It will scroll down because there are a lot of functions in this library. So it will go to the specific function, identify the function, click on the function name, you will get the function code. Because the argument here is equal underscore variance is equal to true. But is our variance equal? No. That means we have to give an argument called equal underscore var is equal to false. Since our variance is not equal. You can also perform t-test when the equal variances are there. There are two t-tests, assuming equal variances, assuming unequal variances. Two sample independent t-tests, there are two tests. Assuming equal variances, assuming unequal variances. Now, assuming equal variances only you will find in economics data. Interest rates. For a longer period of time, Japanese interest rate is 0. If the interest rate is 0, variance will also be 0. No change. Japan is a deflationary economy. In Japan, if you deposit 100 rupees in the bank, you will get 99.5 rupees back. They deduct 5 rupees. Whereas in India, if you deposit 100 rupees, you will get 104 rupees back. 4% is the savings interest rate. Minus 0.5 is 0.05 is Japanese interest rate. That means if you deposit 100 rupees in Japan, you will get less than what you deposit. Negative interest rate. Their interest rates are 0. Because that's a developed economy. See, if you want to put they don't want people's money. They don't want people's money at all. They want the people to spend their money, go abroad, do whatever, everything. They give free money to their people. They give everything is free. Medical is free. Everything is free for their people. On top of it, they will get money also. They don't want it in bank. If the money is in bank and they don't borrow, Japanese guys don't take loans. They don't use credit cards. That is against their culture. Now, bank has money, they can't give credit cards, they can't give loans. What will happen to the bank? What is the business of bank? Take deposits, give it as credit cards and loans to the other people, charge interest from there. They'll charge 18%, 28% from them. They pay on deposit 8%. The different 10% or 20% is their bank margin. Their banks don't have that option. To discourage people from saving money. In Germany also same scenario. They don't want people to save money in the bank. They want to go abroad, enjoy it. They will give you money, their social security, education is free, medical is free, everything is free. Public transport is also free. So they don't know what to do. But whereas in India, everything is cost. The banks need money, right? They want money, deposit. That's why our interest rates go up and down. Whereas in Japan, Germany, US also, very marginal growth will be there. And we Indians think, India is doing great. You see all that WhatsApp memes and all, no? India is the only country going at 6%. How can you compare India with Japan or US? They are developed economies. We can't even compare with them. They are 10 times bigger than India. They have infrastructure, they have money, their currencies are very strong. How can we compare? All the BJP bucks and all this send this money, Facebook and all. And people believe with them. People who have right economics knowledge, they will know. You cannot compare a developing economy with a developed economy. Germany, Japan, US, Canada, they are far developed economies than India. Even China, where education is free, health is free. Is education, health is free in India? Yeah, they are free, but are the quality maintained? No. There are no private schools in China, only government schools. Anybody, rich person or poor person, has to study in government schools. In US also, private schools are not recognized by US government. It's your risk. Rich people kids study because they don't want degrees, but the school system is free of cost. So that is what happens. So variance is a very important aspect. You need to understand variance. For some, it's in economics, we look at variance. Public expenditure, we look at variance, which is very important. But for rest of the data, variance will not be equal. It will be always unequal variances only. Now we have split the data. Now we will conduct the test. From scipy.stats, import t-test underscore in.
Google. Equal-weighted equals to policy. NaN policy and permutation equals to
NaN policy is if there are missing values. But we don't have missing values. Generally, we should not have missing values. Non-value, propagate NaN values, they are all for what you call academic studies, not for business. We don't use them in business because in business, we make sure before we conduct the test, there are no missing values. So propagate means it will keep them as missing only. Raise means it's an error. Omit means it will remove. That's wrong, actually. We shouldn't do that in business. So permutation is not required here. That is required for p-values, that when you have infinity as an output, then we get permutations. But we don't generally get infinity as output if your data is clean and proper. Okay. T-test underscore end holiday 0 dot cnt comma holiday 1 dot cnt comma equal underscore var is equal to false. We have imported the test function and we have conducted the test function. Now we got the p-value. NumPy, it's a sublibrary of NumPy.
Then we can say
NumPy. You can't use NumPy. Sublibraries have to be used from standard syntax. I've given you this structure in the first session only, right? That is the reason why I gave you the structure. So in the Python basics, I've given you the library syntax and structure. See? All the sublibraries of Python, NumPy must be called with from and the library name. See, in data science, there is always relation between one and the other. So whatever notes I am giving, I will explain to you in detail whenever, as and when it is given. P statistic is equal to mean 1 minus mean 2 divided by root of variance 1 by n1 plus variance 2 by n2. Mean 1 minus mean 2 divided by variance 1 by n1 plus variance 2 by n2. This is how the T statistic, this value which you see here, 1.70468. You see here statistic value, right? This value is calculated using this formula. The statistic formula 1.70 is calculated using this formula. Now you can try. 4527.10 minus 3735 divided by root of 3721,094.81 divided by 710 plus 74. Hello. Good morning. Yeah, Vikram. Okay. Oh, good. What? Rows and columns. Guys, remember these are very important things. Shape gives you what? Number of rows first and followed by number of columns. So the 1.704 what we got is based on that formula.
So,
Hmm.
let's say if we put two over there, what generally happens to the output?
It rejecting the null, which is completely wrong. That is what? Actually, it's what? Failed to reject null. It is completely wrong. The interpretation is wrong completely. It's a blunder. So you should not use equal underscore var until the variance is equal. Otherwise, you'll get opposite of the test. So if you want to calculate what was the value? 4527.10 minus 3735 divided by square root of open two brackets. What is the first one? 37,210,9481 divided by 710 plus open bracket 4424 084 divided by 21. Oh, VP dot rescue. Hmm. Yeah, that's right. You got the same value, right? 1.7046. Rounding off, some marginal rounding off error will be there, but otherwise it will be the same. Here there is a T statistic formula. You understand? Good morning. Okay. Yeah, sure. Yeah. Yes.
Can you explain how to interpret variance to standing? Better for understanding the equation of oscillation accounting. So, if you're taking variance over here, like every day standard deviation are good. And once we can see that there's a minimum of certain amount, like the same which you use for data of salary. So how do we find out the square variance would be certain amount, the square standard deviation is square root of that. So how do we interpret it?
The interpretation part, we will only take standard deviation. Variance is used in calculations only. Variance is not used for interpretation. Variance is used for only in formulas and calculations. If you want to interpret, you have to interpret only on standard deviation. Standard deviation, lower the better. There is no fixed range for standard deviation. Lower the standard deviation, the better. Now, how do you decide which is the lowest standard deviation? Depends on the mathematical unit. Is your data in tens, hundreds, thousands, lakhs? Based on that, your standard deviation metric will depend. If your data is in hundreds, a standard deviation of 10 or between 10 to 20 would be a lower standard deviation. Anything above it will be higher. If your data is in ten thousands, then your standard deviation will be in thousands. Somewhere around 5,000 will be my preferred standard deviation. So there is no fixed range for standard deviation. The lower the standard deviation, the better. It depends on the mathematical unit of the data, whether your data is in tens, hundreds, thousands, lakhs, or crores. Yes. High standard deviation. High standard deviation. For our data, I would have preferred a standard deviation somewhere around 200 or less than 200. So standard deviation is high. Why? Because there are observations in one category 710, the other is 21. There is lot of data values also are different here. There are some 21 observations which are holiday oriented, which drastically affect the demand for the bicycles. It might increase drastically or it might decrease drastically. So suppose if both the categories are say 350, something like that, then you will not have that huge standard deviation. Standard deviation will be level, equal. See, what is the formula? X minus mean divided by n minus 1. The n also has a role to play in standard deviation, right? What affects standard deviation? The mean affects the standard deviation and the sample size. Sample size also affects the standard deviation, right? The denominator. If the denominator is smaller, what will happen? The effect will be larger. If the denominator is larger, the effect will be smaller. See, 1 divided by 4, 0.25. 1 divided by 10, 0.10. So the denominator has an effect, right? If you keep the numerator as constant, but in our case, numerator also will change because mean is again differentiating factor, right? So when there is a difference both on the numerator side and the denominator side, and the denominator is having a big difference, obviously your standard deviation will be higher. Not like you can't fix it. It depends on the data you have. It is judgmental call. So what is the right standard deviation? Nobody can define until unless you have a data and you do it. In this case, our standard deviation is very high. Directly also I can see, the standard deviation is very high. Mean is 4,000, standard deviation is 2,000. That's almost 50%. So the mean is the variations, right? Or you want to do it, okay. See the variations? This is a plot. This suggests what? High standard deviation, right? There's big deviation. What is standard deviation? Very high deviations are happening, right? If they are smaller like this, like your ECG in a narrow range, then you can say standard deviation is smaller. But look at it. It's very, very up and downs, high and also. It indicates standard deviation. The visualization also indicates standard deviation. If you do a dot plot also, they will be split down a wider range. What dot plot in Python? Right? So dot plots are not there, only line plot is there in Python basics. So generally I'll show in Excel also, we can do a dot plot. Okay, this is the format for t-test. Now I want you to, since the data is already split, test null, the average wind speed on holiday 0 or 1 equal. Wind speed. So first do group by, then null and alternate. Already data is split, so don't split the data, just directly conduct the test and interpret. First do group by, then from the null and alternate. Data is already split. So holiday 0 dot wind speed, holiday 1 dot wind speed. Now group by, you have to do two things. You have to do mean and you also have to do variance. Hmm. You can use. Already it's showing a non-product value, na? Why do you need to download? It is already showing you what you call non-rounded off value only. Yeah. No, don't round off. If you round off, it will be 0.0 something will come. You should not round off. Remove the NP dot round. You will use NP dot round when you get E plus something as output. Until then, don't use it. When your output is E plus, even that also number 3 and 4 also you can take it. But some of you might get confused. That's why I'm using NP dot round. But it is 3.8 E plus or 4.8 E plus, which is different only. Exactly same variance.
Even if it's not.
Typically, exact variance means 0. Interest rates don't change for years, the variance will be 0. Like what happens with Japan and Germany, they don't change. 0 interest rate in Japan is from 1992 onwards. For the last 20 years, the interest rate is 0 or close to 0. Whereas in India, the interest rates moved from 11% to 6%, or even I think 5.4 was the last Indian interest rate, lowest. Highest went up to 12% also. Because borrowing rate, interest rate, how much the country pays on getting the money from foreign lenders. Now I think 10-year bond is around 7%. That means if you look at India's 10-year bond, so as of November 21st, 7.288. That means India needs to pay 7.288 interest to get 100 rupees loan. Whereas if you look at USA, they just need to pay 3.79%, half of what India pays. That too now they are forced to increase. Earlier it was also 0. And if you are looking at Germany, see, 2.017. 2.017, Germany. France, 2.488. India is 7.78. No, from any other country, if you are borrowing, you have to give the bond. Anybody can buy the bond. It can be other governments, it can be companies, it can be investment banks. Anybody can buy the bond, and Indian government will pay interest of 7.28 yesterday. The interest rates also change every day. Who? Japan. Or close to 0%. Because they are the stable, you will get your principal back, right? See, when economy goes down, see, Japan 10-year is 0.252. close to 0.25% is the interest rate they're going to pay. That too recently they increased from 0, the new prime minister. So people buy more Japanese bonds than Indian bonds because Japan is known to be the most stable market. The economy is strong. In India, all things are faked. All our deficit is wrong, everything is wrong. We have a lot of corruption, lot of things are bad. Our roads are not good, everything is bad in India. So why would anybody want to invest in India? Only when you give high interest rate, they'll come and invest in India. Now, Brazil is even worse. Brazil has political crisis. Recently, they have got a new president. See, Brazil want to borrow, they have to pay 13% because they went to political crisis. Lot of election, ultimately 2 times they have conducted election and ultimately they got a new president by a very, very less margin. And now the country is very unstable, unemployment is high and all. They have to pay 13.5% to borrow. So this is what happens when your economy is not doing good. And when you have such very close values, your variance will be less. So variance will be very less. Whereas in our case, our interest rates change a lot. If you look at India's interest rates, they changed a lot. So if you take 10-year, so our interest rate in 2014 was around 8%. Now it is around 7%. I think this is normal interest rates, which is set by, I think this is your what? Interest rate, not the yield, bond yield. This is your interest rates. Now, if you look at our 25-year, see, highest point was 12. And we crossed 8 also multiple times. Now we are in bank interest rates is around 6%. FD. So this is the change we are having. Now, if you look at Japan, in the same data, see, negative minus 0.02 to minus 0.1 now. Now the negative interest rate is still going on. That means if you put 100 rupees, you'll get only 99 rupees back in Japanese bank. So they are still on a negative interest rate. See, 25 years, they never cross the interest rate of 0.4. Whereas in India, it is 12% to 6%. That is the level of interest rate. So when you have data like this, when you have straight line, what will be the variance of a straight line? 0. That means you have to use an equal variance, right? So that is where you will use. In economics data and all, you will see equal variance. In normal business data, we don't see equal variance. Got it? All right.
So can we invest in virtual bank to get that interest rate?
Yes, if you want to take risk, you can invest. Anything can happen. The government may declare bankruptcy. Your money will be gone. If the political instability continues, the currency falls and all, they may freeze the loan. That means you might get your principal back, but not immediately. It will take time. Hello? ఎక్కడున్నావు అమ్మా? స్ట్రైట్ మస్జిద్ రోడ్ లోనే స్ట్రైట్ గా వస్తే లెఫ్ట్ సైడ్ 5వ అపార్ట్మెంట్, సాయి మోహన్ ఎన్క్లేవ్, పింక్ కలర్ అపార్ట్మెంట్, బ్రౌన్ గేట్స్ ఉంటాయి. 302. Investment is very risky. If you are trying to invest in developing countries, there is always risk. There is lot of risk in India also. That's why we have to pay 7% interest rate. To attract investments, if the people don't want to take risk, they'll go to happily invest in Japan. At least their principal will be secured, right? And Japanese government can never default because they have so much of dollars and that's a big economy with trillions and trillions of dollars in their reserves. They can pay any debt. But we have hardly, how many dollars? Modi was saying we had $600 billion of dollars available as reserve. Now they have fallen down because our rupee is depreciating, right? It went from 69 to now it is 82, historical high. Because all the media channels are owned by either Ambani or Adani, they are not telling it. Ambani owns all the media channels. Na? Times Group is owned by Ambani. NDTV is owned by Ambani. India Today, TV Today network is owned by Ambani. Whichever is left out, owned by regional BJP leaders like Chandrasekhar. Republic is owned by S. Chandrasekhar. He's a BJP Rajya Sabha MP. Arnab Goswami and he are partners. So they don't tell these facts. So, only people in South India know these things. If you go to North India, they don't know anything because there is no newspaper penetration, there is no radios, no TVs, nothing. They don't have electricity at all. UP, Madhya Pradesh, Rajasthan, they don't have anything except WhatsApp. Except WhatsApp, nothing works there. And in WhatsApp, only BJP groups work. You try it. You go and try in UP, you will see all sorts of things there.
So then, how will we pay also for the?
Who? Uttar Pradesh is the largest state. And it has largest industries. You know Ghaziabad, right? Ghaziabad is an industrial state. Noida. Gujarat also, because what happens is they are industrial states. Whereas Telangana is agricultural state. Andhra Pradesh is agricultural state. Tamil Nadu is agricultural state. No, Telangana is more agriculture. IT is only in Hyderabad, na? Mostly it is agriculture. Hello? దాటిన తర్వాత 2వ అపార్ట్మెంట్, అది దాటిన తర్వాత పూర్ణిమ మ్యాన్షన్ పక్కన సాయి మోహన్ పింక్ కలర్, దాంట్లో 3rd floor 302 పైకి వెళ్ళండి, కార్ కీస్ ఇస్తారు. Whereas Telangana is purely agriculture. Only Hyderabad is IT, right? What factories we have? If you go to Gujarat, half of Gujarat is only factories, chemical factories, pharmaceutical factories, all sorts of factories are there, textiles, all of them things are there in Gujarat. Gujarat is purely industrial. Western UP is purely industrial. Eastern UP again agriculture. So that's how it works. When you have factories, Himachal Pradesh, you take Himachal Pradesh, the plains are all medical companies only, pharmaceutical companies. Climate is cold, Solan and all those places. But if you go to hills, they are very poor. Hills, non-hilly area will be the plain region. That is where you have development. If you go to Himachal Pradesh interior, no development. All hilly areas, no transport, no roads. Some states that will be less because the factories are also less. So we have to look at different parameters, then we have to compare. You can't compare with apple, just like apples to apples or like that. It has to be done based on certain metrics and parameters. So that is where data has to be interpreted and compared. All of you have that day Excel sheet. Open the day Excel sheet. All of you go to the data tab. Do you see data analysis toolpack on the right extreme corner? Data tab. Right extreme corner. Do you see data analysis? Here, you will see on this side data analysis. You have or not? No. No, if you don't have, go to file, options. Click on file, options. Got it? In options, you will see add-ins, bottom to one. Click on add-ins. Add-ins. In the add-ins bottom, you will see manage Excel add-ins. Click on go. Click on go. A window will open. Tick mark first one, data analysis toolpack, and tick mark last one, solver add-in. Open completely. Options below. Add-ins. Analysis toolpack is the last one, solver add-in. Click on go. Manage Excel add-ins go. First one and the last one, data analysis toolpack and solver add-in. Hello? Yeah. చెప్పండి లేదమ్మా శాలరీ సర్టిఫికెట్ అయితే కుదరదని చెప్పారు శాలరీ సర్టిఫికెట్ data tab and data analysis. Okay, so in the day sheet, let me zoom it. In the day sheet, go to the holiday header, go to the home tab, sort and filter, apply filter. Go to the holiday header, home tab, right extreme corner, sort and filter, apply filter. Sort and filter. Okay. Go to the holiday header, home tab, sort and filter, right extreme corner, apply filter. Now go to the drill down next to holiday. You'll get that arrow marks next to the names. Click on them. Unselect all, select 0. Unselect all, select 0. Okay. Now you can see holiday 0 is selected. Go to the CNT column, Control Shift down arrow, Control C, go to a new sheet, paste it here, CNT underscore holiday 0. So you have to apply a filter on holiday. Now unselect 0, select 1, and go to the CNT column. Select the observations. CNT underscore holiday 1.
Holiday 0 column,
No, CNT.
ECND.
CNT column you have to paste for holiday 0, CNT column for holiday 1. So apply filter on holiday. Same sheet like this. Adjacent columns without any gap. Got it? Go to bottom filter. Right extreme column. Click on filter. Now you got the down arrow, click on that. Unselect all. Click on that. Now select only 0. Click OK. Now you will see below values. Copy the CNT column. Go to the CNT. No, column, complete column. Header, go to header. Go to the header. First cell of header. Not like. Control that you press down arrow. No, control that you press down arrow to hold them together. First cell, control that, down arrow. Okay, use like you select and next step you can use. Got it? All right, all of you got this? Now go to the data tab. Data analysis. Data tab, data analysis. If you scroll down to the end, you see t-test 2 sample assuming equal variances, t-test 2 sample assuming unequal variances. Assuming equal variances, assuming unequal variances. I told you, no? So same thing is there in Excel also. What we have to use? Assuming unequal variances. In the end, the last one, t-test 2 sample assuming unequal variances. Click on OK. Variable 1 range, click on the color box, go to the first cell of holiday 0, Control Shift down arrow. Variable 1, select the holiday 0 column. Variable 2, select the holiday 1 column. We will give labels, no? There is option called labels. Labels, tick mark labels, because we are selecting the labels also. Otherwise, we will not know what is what. Then alpha is 0.05, 95% confidence level. Output range, select some empty cells in the same sheet. In the same sheet, select some empty cells. Output range. Variable 1 range, select the CNT holiday 0. Variable 2 range, CNT holiday 1. Tick mark labels. Let the alpha be 0.05. Output range. Click on the box. Select some empty cells. Multiple cells. 2, 3 you can select. And click on OK. You will get the output. You will get the exact t statistic what you got in Python. You will get the exact t statistic what you got in Python. And the two-tailed test value is also exactly what you get in Python. You can see the mean variance is exactly what you got in Python. Sample sizes also. So what is the thing? Is equal to if this less than equal to 0.05 comma reject null else fail to reject null. So we got fail to reject null. You can simply give the if statement, logical test. If the p-value is less than equal to 0.05, reject null, or else fail to reject null. Our p-value is greater than 0.05, we are rejecting the, failing to reject the null. You got the data? Now go to the data tab. Data on top. Data tab. Right extreme corner data analysis. Scroll to the end. T-test assuming unequality. Scroll to the end. Assuming unequal variances. Click OK. Variable one range, select it. Click on the arrow next to the box. Minimize it. Now go to the first cell. Control holidays. Clear the holiday. Leave column. Select the whole column. Go click on the arrow again. Next. Now click on the variable two range arrow. Arrow. Click on the arrow. Variable two. Scroll up. Scroll up. Yeah, just sit on control shift on. No, click on labels. Output range. Click on output range. Click on the arrow. Select some empty cells. Not there. Side. Some empty cells. More than one. Multiple selects there. Enough. Go back. Okay, take off. Got the process, all of you? Apply the filter on holiday, select the CNT column, paste it into new sheet, go back, unselect the previous, select the next one, copy the CNT, new sheet, and connect it. Now, similarly, do it for wind speed. Holiday and wind speed. That's the second test we have done, right? Now, go to the day sheet, apply filter on holiday. It's already day. You have to select 0, select the wind speeds of 0, then 1, select the wind speeds of 1, connect the test. So I'll go to the day sheet, unselect all, select 0. Then I'll go the wind speed column, Control Shift down arrow, Control C, new sheet, wind speed, holiday 0. Then I'll go back, unclick 0, click on 1. Wind speed, data tab, data analysis, to sample assuming unequal variances. Labels alpha. So T stat is minus this. This is the p value. Fail to reject null.
Sir, when we click data analysis, we get this two options. Do sampling assuming unequal variance. So first we need to check variance in Python, then come back to it.
In Excel you can check now. Why you have to go to Python? In Excel you can check mean as well as variance, average and variance, not mean. You can do average and it's given here, right? See here. Or you can check beforehand using dot var is equal to var. Hmm. That I will share later, once you have. That later. Once we have gone through the data pre-processing, otherwise you're not able to understand anything. I'll share those things later. All the files will be shared. We'll work on the data, same Medicare data for the month of August. That was July. So by the time we go, it will be December. So in December, we should get data for October. We'll work on October data. Its data is released every month. We'll work on the same data, what he has done, that is done in the classroom only. Only thing is he has done some additional hypothesis tests, that's all. And some additional visualizations he has done. Otherwise, everything will be discussed in the class. That is the July data. By the time we reach that stage in our thing, it will be December. So we will have access to October data, October 2022. So that will be our data, we will work on it. No, still we are just doing the first test. There are 3 more tests to be done. Actually, there are 9 to 10 tests are there, but in business we use only 4.
So this is two data.
This is t-test. 2 sample independent t-test. The hypothesis test we have used is 2 sample independent t-test, where the categorical variable has exactly 2 levels. Done? All of you are done? Pardon? No. See, generally we do what we call EDA, data pre-processing, hypothesis testing, and data pre-processing again. And then we go to model selection, variable selection, and then model building. Before after data processing, we do hypothesis testing. After hypothesis testing, we will do data pre-processing again. So data pre-processing will be done till the point your variables are selected. A lot of steps are there that will be discussed later. There are many steps. All right, all of you are done? Hmm. Mean difference must be there. Difference in means is a fundamental assumption. Without, if the means are not different, you should not conduct it. If means are identical, you should not conduct this test. So one variable numerical and other variable categorical with more than two levels or groups or classes, ANOVA single factor or one-way ANOVA must be conducted. Exactly two levels. In categorical variable, we conduct two sample independent t-test if there are more than two. That means it can be 3, 4, 5, 10, 20, 30 or 100. You have to conduct a test called ANOVA single factor. ANOVA single factor is a hypothesis test used when your categorical variable has more than two levels. Anything above two levels, you have to conduct ANOVA single factor, also called as one-way ANOVA. The null hypothesis is, so the process is same. We have to do group by bicycle data dot CNT dot group by bicycle data dot season dot mean. So we can see here we have more than two levels. More than two levels or groups or classes in the variable season, which is a categorical variable. And the means are different. Means or averages are different. So both conditions are met. More than two levels and the means are different. More than two levels and the means are different. The null hypothesis is there is no significant difference in average CNT of different seasons. Same statement, paste it down, change the null to alternate, remove the word no before significant. There is significant difference in average CNT of different seasons. No significant difference. H0 means mean 1 is equal to mean 2 is equal to mean 3 is equal to mean 4. Alternate hypothesis is mean 1 not equal to mean 2 not equal to mean 3 not equal to mean 4. No significant difference, significant difference. These are the means. For season 1, the average is 2604, season 2, 4992, season 3, 5644, season 4, 4728. These are the different averages for different seasons. The null and alternate. Now, we have to split data. We have to split data. Season 1 is equal to, what is season 1 basically? If you look at the data dictionary, Season 1 is spring, summer, fall, and winter. Spring is equal to bicycle data dot season double equals to 1. Season spring के बाद fall. You can copy the command from top, Control C, Control V, change the 1 to 2. Summer, paste it and change it to 3. Winter, right? Winter is equal to paste it and change it to 4. Spring, fall, summer, and winter. Print spring dot shape, print fall dot shape, print summer dot shape, print winter dot shape. Done. Now, SciPy dot stats, go back to the functions page, Control F, ANOVA. Now you type in SciPy dot stats page, Control F, ANOVA, you will see here. Perform one way ANOVA. F underscore one way. Statistic and p-value. It will give you the statistic and p-value. F underscore one way. The function is F underscore one way. The one way ANOVA tests the null hypothesis that 2 or more groups have the same population mean with different sizes. From SciPy dot stats, import F underscore one way. F underscore one way spring dot CNT, comma, fall dot CNT, comma, summer dot CNT, comma, winter dot CNT.
So in this way, we can, do this, not like the variance is not.
Variance does not matter. Equality of variance does not matter. The formula is different. It's a very large formula. Yeah. Here we have significant difference. You can see, right? It starts from 26042 to 5644. There is a big difference here. So that is what it's saying. The difference is very big. So that means the dependent variable is affected by season. The dependent variable is affected by season. Whereas the dependent variable CNT is not affected by holiday. The independent variable wind speed is not affected by holiday. The other two t-tests we have done, where the p-value was there, it shows CNT is not affected by holiday. CNT is our dependent variable. We are trying to predict this CNT, count of bikes. Here, p-value, we are rejecting the null. That means season has an effect on count of bikes rented. Whereas holiday does not have any effect. So when you're choosing variables, you can ignore holiday, but you cannot ignore season. That is what reject null means. The variable has an impact. Fail to reject null means the variable does not have impact on the other. Reject null means one variable affects the other. Fail to reject means both the variables are independent, no effect on one another. E minus 67. E minus 67 means after 66 zeros. 0 point after 66 zeros, the value will come. E plus means before the dot, minus means after the decimal. E plus means the value starts before the decimal. Minus means the value starts after the decimal. After 66 zeros, you will get it. You have any doubt, you can do that. NP dot round. Right? I'm giving 80 decimals, still it is not coming. If it is minus, then definitely it is less than 0.0. Not even 0.5. It is less than 0.0. Greater means it is definitely greater than 0.0. And if we are looking at the formula, it's a very large formula. They might not ask you the formula, but they will ask you what is the distribution and how it is calculated. See, these are the formulas. The final F statistic. This is the final F statistic which is calculated by mean square between by mean square within. Before that, you have a lot of formula, you have to do a lot of calculations, sum square within, sum square between, with degrees of freedom. K is the number of variables, number of observations. So all these things you have to calculate. Finally, you will get the F statistic, this value. So a lot of formulas are involved in ANOVA calculation. So this is the all the formulas that are involved in ANOVA calculation. Okay.
So when will we purpose is announced? When will we purpose is so to be announced?
ANOVA is most common test used in industry. Whether the purchases made by different occupations is same or not. E-commerce data, when you have purchases, whether different people making purchase, or take for example your bank data set only. You worked on bank data set, right? That is selling the deposits. This bank data set is all about selling the deposits, whether the customer bought the deposit or not. Now here, in marital, we have more than 2. Or if you take job, more than 15 types of jobs are there. Whether the average balance maintained by different jobs are same or not, ANOVA will tell you. Then accordingly, which are important, which are maintaining high balance, the bank will give them more offers. Which are maintaining low balance, the banks will not give them offers. Same thing in e-commerce and retail. People who are buying on an average more will get more discounts. People buying less will get less discounts. So all those things of decisions regarding giving discounts and giving offers is decided based on this hypothesis testing. If the hypothesis testing says the average balances are not does not make any difference, then bank will not give any offer to anybody. But if the test says some of them are doing higher purchases and they are doing significant amount of purchases, then the bank will give those people higher offers. Who doesn't do more purchases, they will not get offers. So hypothesis testing is used in generating offers, discounts. Even in telecom, your SMSs of offers come based on your spending, average spending. They do the grouping, and based on the grouping, they'll test the differences. If the differences are significant, then they will start for the higher group, high offers, lower group, lower offers. So all these decisions are made by hypothesis testing. I can't simply go and say I will give offers to this. No, it is based on statistical methodologies on which the bank, telecom companies like Airtel, Vodafone, they all make decisions on data. And one of the common tests they use is T-sample. ANOVA. Now, to check whether male customers are important or female customers are important, you have to do T-test. The classic example of T-test is male and female, exactly 2 levels. Whether male customers are paying more telecom charges or female customers are more. If male are paying more, you give them more offers. If females are paying less, give them less offers. Simple as that. All the decision making has to be done on a statistical test. You cannot randomly give offers to anybody. You, based on statistics, based on data, that offers will be generated. And it's all based on hypothesis testing and exploratory data analysis and grouping. Once the exploratory data analysis is done, the grouping will be done, then the hypothesis test will be run, then the system will be given what should it do based on the hypothesis test. The significance values are taken, and based on the significance values, it will generate offers to the customers. So all these tests we use in business. Because otherwise, how can we send offers to some customers and now we can't send it? Even the regulator will ask on what basis you are giving offers. Then we have to show the output of the hypothesis test. Based on the hypothesis test conducted on the customers, we found out this is the pattern. That's why we are giving these customers high offers, these customers low offers, and some of them zero offers. They have to report to the regulator also. Try. Same thing with banking. RBI. Why are you giving more loans to particular customers? Why are you not giving any loans to customers? The Insta loans which you get on, right? No, nothing. You click on the loan in net banking, you'll get the money in your account in seconds. No verification, no documentation, nothing. They're all generated based on system and hypothesis. Based on a credit profile, credit scores, and all those things. So everywhere we have to use this hypothesis testing.
About final law, we have to put it on status.
Not in software. Manually, you have to do these calculations, but software, you just need to have the function. The function will use the same formulas in the back end. The function will use the same formulas in the back end. The statistical formulas cannot change. The statistical outputs cannot change. They have to be absolutely correct. Otherwise, the software will be rejected. Whatever software you use, these are the formulas. Whether you do manually, these are the formulas. Test null, the average wind speed of different seasons equal to group by, then null and alternate, conduct test because the data is already split, and then the interpretation. Done. What is the interpretation? There is,
No much difference in the meaning.
hmm,
The margin was but it affected the.
this, what you call, what I told you, the denominator. The denominator in case of holiday was 710 and 21. So here, what is the denominator? 181, 184, 188, 178. Denominators are very close to one another. When the denominators are there, when there is a difference in denominators, it will be failed to reject. When the denominators are close to one another, it will be rejected. This is very, very, the difference in means is very, very small. But so the denominators are also very small, right? The difference in denominators is also very, very small. There, the difference in means is larger. The denominators are also larger, 7, 10 and 21. Whereas here, all the denominators are very close to one another. Even the top, the numerators, which we see here, the means, they are all close to one another. So what happens? Marginal difference also will become a very big difference. So you are thinking it's a small difference, I'll ignore it. No, but statistics says the smaller difference is also a very, very big difference because the denominators are very close to one another. So the differences are very big differences. You can't treat them equally. Then wind speed is not dependent, is not affecting the seasons. That means there is no relationship between wind speed and seasons. Here it is saying there is a relationship between wind speed and seasons. Reject null means relationship. Fail to reject null means no relationship between variables. In your layman terms, if you want to remember, reject null means relationship. Fail to reject null means no relationship. Simplistic terms. So here wind speed and seasons are related. There is a relationship between wind speed and seasons. Yes, you have to do hypothesis testing, you have to do all. Typically, those variables will be important variables, not all variables. So your client will give you either important or significant variables, or you have to identify them and send them to your client based on your subject knowledge and domain knowledge. And then once you agree that these are the important variables, then you go ahead and do the testing. Hypothesis testing is mandatory. See, last Sunday there was a analytics with the hackathon. PJ22, one of the student is ranked 70. The data is this jobathon happened on last Sunday, day before yesterday only. He created the MCQ test, 30 marks, he got some 21 or 22. Then they gave the data set, he performed it. This is the time series data. On this time series data also, he has to do a hypothesis test. See? He has to submit the code file and all. He submitted, now he is in waitlist. He is ranked out of 6,000 participants, he is ranked around 70. So he is in waitlist. He will definitely get a call from some recruiter in next 1 week or 10 days. So see, this is time series data. So he has to do a hypothesis test. And then based on the hypothesis test, he will interpret and he will do the model building and analysis. This is his predictive model which he built. This is the forecast based on the historical data. And then he submitted the competition file and all, and then used multiple strategies and multiple models. Now he is on the shortlist and wait list, so he will definitely get a call. So hypothesis testing is part and parcel of data science. You have to do it. Without doing it, you can't explain why some variables are important, why some variables are not important. You can't randomly choose. You have an option. You have an option. You want, you can remove it. Or include it in the model, anyway, model will remove it. To doubly make sure, put it in the model. If it is not significant, model will anyway remove it. Make it insignificant. IDs, that's a different scenario. IDs are different. They are not related, so we will remove them. No effect. So all of you go to the Excel sheet. Go to the day. Remove the filter on holiday. Select all. Remove the filter on holiday by selecting all. Now, apply the filter on season. So unselect all, select season 1. Go to CNT. Control Shift, down arrow, Control C, new sheet, Control V. CNT, fall, sorry, string. Then go back to the day sheet. Unselect 1, select 2. Copy the CNT. CNT, fall. Go to season, unselect 2, select 3. CNT, summer. Then go to day sheet, season, unselect 3, select 4. Go to the CNT column. CNT, winter. All right, all of you split the data. Mummy. Sorry. All right, all of you split the data. Go to data analysis, data tab, data analysis. The first one, ANOVA single factor. The first option in data analysis, ANOVA single factor, right? Input range. Select from winter till the end. Oh, we have to extend. Use shift and down arrow till the last. Select till the last. You can see, right? Some column will be large, some empty cells will be there. Don't bother, no issues. Select till last. Input range, all the 4 variables in one go. You have to select till the end. Then labels in first rows. Alpha is 0.05. Output range. Go to the top, select some empty cells. And click OK. This is the p-value. So these are the arguments which you need to select. Select the complete data of all the 4 columns. Complete data range of all the 4 columns. Then tick mark labels in first row. Alpha is 0.05. Output range, select some empty cells and click OK. Got it, all of you? You got the same output what you got in Python. The F statistic and the p-value are exactly same. Mean square, sum square, there are a lot of formulas. These are the formulas. These are the formulas. Got it, all of you? These are all many formulas. Okay, all of you, if you want to calculate them in Excel, you have a simple function called ANOVA single factor. This whole calculation uses the same formulas. What we use in the actual formula thing. Take for example, SS between. Is equal to open bracket x minus mean whole square plus open bracket hello Swiggy amma ఎక్కడున్నావు సాయి మోహన్ ఎన్క్లేవ్ పూర్ణిమా మాన్షన్ పక్క బిల్డింగే సాయి మోహన్ ఎన్క్లేవ్ పింక్ కలర్ అపార్ట్మెంట్ దాని పక్క బిల్డింగే సాయి మోహన్ ఎన్క్లేవ్ బ్రౌన్ గేట్స్ ఉంటాయి చూడు అపార్ట్మెంట్ కి is equal to sum of oh, we got a different value. Why we got a different value? X minus mean whole square sum square within sigma you can make a mistake somewhere. 1 second. We have done it correctly only. Then why it is saying अच्छा n into n into we have to give a okay, we have to multiply with n. Okay, got it. I'm doing the old way, so. Okay, count of observations is spring is 181. This is equal to 184. This is equal to 188. This is equal to 178. Right? So SS
This is why I will never buy an apartment. This is the treatment distribution here is going to be our p-value in one way and
See, when they are looking for you at data scientist position, they will ask you. If you are looking at, see, it all depends on the job profile. If the job profile involves calculating hypothesis, they specify in the job description which hypothesis tests you have to master and which they generally use, regularly use. Those things they expect you to understand. That's then the questions will be asked upon that. So we have the group 1, group 2, group 3. We calculated the means and into the sum. And into 83.4. This is SSR. Okay. SSE. SSE we have corrected correctly only. Group 1, 85 minus 83.4 whole square, 86. So we have to separately calculate for group 1, group 2, group 3, and then we have to total it. That is the error I am doing. I was calculating separately. SSE, then we get 1106. So we have to calculate separately each group and then we have to sum total them for corresponding things. Is equal to open bracket 985 minus 2064 F4 to the power of 2 is equal to open bracket 2077 minus 4992 F4 to the power of 2 is equal to open bracket 4385 minus 5664 F4 to the power of 2 is equal to winter 2395 minus the mean of winter F4 to the power of 2. Then we will go till the point. No. We have to remove this. 6, 7, 8, 5, 6, 6, 8, no. Double click this formula till the point where it is there. These things will delete. This is correct. Winter. Again, in the bottom, we will see common formulas. Delete. Okay. Print auto sum. Auto sum. We are summing the x minus means. So is equal to totals. This plus this plus this plus this. See, we got 17889354. We can go. Hello. अब सिक्योरिटी गेट में दे दो. NMMS यूनिवर्सिटी का बोर्ड दिख रहा है. हाँ, वही उसी के सिक्योरिटी गेट में दे दो. सिक्योरिटी को दे दो. So grand mean is mean of means is equal to average of these four. Then SS BG between groups. SS between groups would be is equal to 181 into open bracket 2604 minus this plus 184 into open bracket this minus this plus 188 into open bracket this oh we got some difference. Okay. So this is sum square within. N is how much? N is 731, right? How many variables we have? How many categories? 4. K minus 1, N minus K. Is equal to 4 minus 1 is equal to 731 minus 4. Total is 730. So mean square would be MSW is equal to this divided by this. MSB is equal to this divided by this. F statistic is equal to this divided by this. 128.78. So these are the whole calculations that are involved. I'll send you the Excel sheet, you can check it.
Still, why did we do all this, we got this thing, right? Somebody-
To understand what the formulas are. So what are all formulas are there, how it is calculated. One thing, second thing is these formulas also help you to improve your Excel skills because there are these are complicated formulas. You will be working in lot of Excel formulas in your real-time data sets. Most of the time, basic analysis will be done on Excel only. So I have implemented all these formulas in the Excel sheet which I got. Some round of errors will be there. So first I have calculated the sum square within, which is the x minus mean whole square for each of the variable. Mean we have calculated, right? Then we calculated the x minus mean for the 4 variables. Then we sum total the x minus mean, sigma x minus mean. Then we added these 4 values. When you add these 4 yellow values, you will get this value. Then we calculate the grand mean, which is the mean of means. Grand mean is mean of means. For all means, you calculate the mean. Mean of all means, you calculated mean. Then we multiply each corresponding number of observations into mean minus grand mean. So the 181 into 2604 minus 4492. 184 into 4992 minus 4492.32325. So number of observations into mean minus grand mean. We get the sum square between groups. Then n minus k. This is n minus k. N is number of observations. N is 731, right? K. K is number of classes. 4. K is 4. Okay. This is k minus 1. This is n minus k. These are degrees of freedom plus k minus 1, which is nothing but n minus 1. This is df1, degrees of freedom df1. This is df2. Now here we are doing mean square between is equal to SSW divided by df1. This is SSB divided by df2. This is SSW. This is SSB. And you get this. F statistic is equal to MSB by MSW. You got this. So these are all the formulas that are there to understand how it is calculated. In actually, in MBA and statistics exam, we give this as a compulsory problem for the students to calculate. This is one of the important tests we do in data science. All retail, e-commerce, banking, insurance, transportation, ride sharing, Ola, all places we do this hypothesis testing using ANOVA. So just check these formulas. We'll discuss again in the next class also. Any doubts, I'll clarify.
So very different previous class,
Previous class? Video is already uploaded. Previous notebook is same, na? We worked on the same notebook, right?